Analysis that we were comparing between Texas and GB show that it is now a larger function, is more cyclical, and so batteries will be charging during the morning. As the initial build out of batteries enter into a market, the majority of their revenues are earned from these frequencies.
I would like to jump on the top 3 impacts on degradation because it has one, if not the largest impact on the degradation of your asset by far.
Hello everyone and welcome to Sinovoltaics webinar. My name is Rasaya Kaitis, I'm Media Manager at Sinovoltaics, and I will be moderating today's webinar on BESS degradation. From the talks with industry leaders, it became clear that the topic is really hot and very important. And we can also see that from a record number of registrations we received for today's webinar. We have delegates registering for this webinar from more than 84 different countries around the globe. And of course, no surprise why. Utility scale batteries are central to the clean energy transition. But recent evidence shows that the systems we rely on may be degrading much faster than expected. Recent research from Modo found that battery energy storage systems in Great Britain might be losing an average of 4% of their capacity in just 1 year, in 365 cycles. And earlier this year, also Modo published another research from the Electric Reliability Council of Texas that revealed even steeper losses of around 7% over the same period of time. So why it is happening? What are the impacts for business operators and investors? And how can this faster degradation be prevented? That's what we're going to find out in today's webinar. Before I introduce our two speakers, let me share a quick housekeeping rules. This webinar will last for about an hour, and 2 expert presentations will be followed by a Q&A session. On the right-hand side of your screen, you can see the Q&A chat. Please use the Q&A chat to submit your questions at any time during the presentations. I'll address the questions at the end of this webinar to the respective speakers. Please also note that this webinar is being recorded and will be uploaded on Sinovoltaics YouTube channel. And if you don't want to miss the newest content updates on YouTube, don't forget to subscribe to our channel. And now let me invite the 2 speakers on the virtual stage and let me introduce them. So we are joined today by Ovais Kashif, US West Market Lead at Modo Energy. Hi, Ovais. Good to have you.
Hi, Rasa. Thanks for the introduction.
At Modo Energy, Ovais leads grid-scale battery market analysis, focusing on US power markets and the evolving economics of energy flexibility assets. He specializes in evaluating battery revenue performance, optimization strategies, and policy developments. His data-driven insights support owners, operators, and financiers across the energy transition. And Modo Energy, to those who don't know the company, is a UK-based data and analytics company focused on utility-scale energy storage and the evolving clean energy markets. And today, Ovais will share his insights on why BESS energy capacity appears to be dropping faster than expected. He will also examine the financial implications of this trend using ERCOT data and compare BESS degradation patterns between ERCOT and Great Britain's electricity markets. The next expert in today's webinar is my dear colleague, Tristan Möhle. Hi, Tristan. Good to see you.
Hi, Raza. Hi, Ovais. Nice being here. Looking forward to the webinar.
Tristan is a Director of Business Development for Central Europe at Sinovoltaics. He brings extensive experience in senior renewable energy roles with deep expertise in business development, project oversight, and supply chain quality. And currently at Sinovoltaics, Tristan helps stakeholders secure reliable solar and BESS systems through rigorous quality control, traceability, and ESG practices. And today, Tristan will take a deeper look at BESS quality from a granular cell level perspective. He'll explain how poor BESS design can affect system performance over time and what measures can be implemented at the factory level to prevent these issues. And finally, before I hand over to Ovais, I would like to briefly introduce Sinovoltaics to those of you who join our webinar for the first time. So Sinovoltaics is a Dutch-German company providing technical compliance and quality assurance for BSS and PV worldwide. We help our clients, utility scale developers and investors with inspections, factory audits, ESG reporting, and traceability audits. And with over 15 years of experience, we have already audited more than 350 PV and BESS factories around the globe, including all major components in the supply chain, such as modules, inverters, transformers, cables, etc. So now, without further ado, I hand over the virtual microphone to Ovais. Please, the floor is yours.
Thank you, Rasa. Right, I'm just going to share my screen. Lovely. So thank you, Rasa, for the introduction. And just for a brief recap, my name is Ovais. I cover our research product looking at the Texas, Californian, and SPP markets in the US, focusing mainly on grid-scale battery energy storage. Today, I'm going to be talking through two analyses. One I conducted myself for the Texas market, looking at energy capacities over the past 5 years, and comparing the results of that analysis to our Great Britain study. Really, the main comparison point between the two is that we see batteries in Texas degrading faster. And what I'm going to be talking through in the first half of this presentation is why we believe that might be the case from an operational and revenue strategy perspective. Tristan will then be covering some of the physical sides of degradation in his section of the talk. So that's the first half. The second half is just going to be talking through where revenues in Texas are coming from for battery energy storage and why we see energy capacity being an even more vital part of the equation going into the second half of this decade. And just a quick recap about Modo Energy, just to build on what Rasa said. We specifically look to provide market insights for grid-scale battery energy storage in global markets from Europe to the US down to Australia, really for the financiers, owners, and operators of the energy transition. What that means is, for the financiers, if you're a project developer, looking to go to the bank to try and get a loan to build a project, we provide price forecasts and investment outlooks for what those investments would return. And then for people with skin in the game, so owners and operators with actual assets online and operating in the market, we advise on day-to-day operations and revenue strategies for batteries. And the reason why I'm laying this out as well is because our insights come from publicly available market data. We don't have any actual assets in the market. And so the results that we see here today are all based off of signals that we can see based off of, again, publicly available data. So without further ado, the results of the analysis that we were comparing between Texas and GB show that battery energy storage in Texas capacities appear to be falling faster than in Great Britain. Now, here you see our forecasted degradation curve. These two lines show they're the same curve for both markets, as you would expect. Most of these systems have the same cell chemistries across geographies, same supply chains. And really what the expected outcome is that as a battery starts to operate in the market, it sees faster degradation towards the start of its life, and this slows down as the years progress. Here we're using cycles to measure utilization. And most of the people in the audience will know this, but a cycle is effectively when a battery has exported up to its total energy capacity. So a 100 megawatt hour battery, every time it exports 100 megawatt hours, that's it performing a full cycle of charging and discharging. And we expect most of these batteries to be repowered somewhere around the 60% mark once 10,000 to 12,000 cycles have been completed. Now, each of these red dots shows a specific battery in both the Texas ERCOT market and the Great Britain market. And what we see here is that, firstly, a lot of the batteries are still towards the first end of this curve in the GB market. We see quite a lot of variance around this line, but mostly within line. And so the average that we see across batteries currently is about a 4% degradation rate. In Texas, the same methodology has shown that batteries, again, towards the start of their life, follow the curve, but there's a handful of batteries that appear to be losing their energy capacity at a faster rate. And in this case, it's 7%. The exact numbers, 4 and 7%, are possibly an overestimation. And to understand why, I think we can step into what the methodology is for actually calculating the decrease in energy capacity across these different batteries. So what we're measuring exactly is the amount of energy that is being exported between imports. And what that means is here we see a chart for a single day for a single battery. The bars on the top end of zero show battery exports, so discharges, and the bottom half shows battery imports. And we see these throughout the day for a single asset. What we use as a heuristic to indicate total energy capacity is the maximum amount of energy exported between imports. And so what you would expect is that if a battery was, say, charging up to its full capacity and discharging its full capacity, then the volume, or if you add these bars up together, would indicate its total energy capacity. Now, in this case, this example is from a 200 megawatt hour battery. If you add up these purple bars together, you get 150 megawatt hours. So it's not to showcase the actual total energy capacity, but just an indication for how much this battery can export. We then track that signal over time. So again, this is one battery over its lifetime. This battery began operation sometime in the middle of 2022. And then for every day, we track the maximum amount of energy it is recorded to have exported. What we then do is we understand how this maximum energy export has decreased over time. So we start with a reference point. In this case, this battery, this 200 megawatt hour battery, exported 191 towards the start of its life. We then track how many cycles it's completing as it goes through, and then look for the second signal, effectively, for indicating what that maximum energy capacity is. In this case, after about 2 years, we see that its maximum energy export in the winter of 2024 was about 178 megawatt hours. And so what we're now measuring is a 6% drop between these 2 points and the amount of cycles completed from point A to point B, which is what produces our chart at the initial, at the start of the article, start of the presentation. Now, a student of you in the audience will know that this isn't an indication for true energy capacity, but really what we're trying to do is estimate this 200 megawatt hour nameplate capacity and how that's decreased over time. And so we're assuming that if a battery is trying to keep a consistent headroom throughout its life, then it will try and adjust how much it's exporting based on how much available energy capacity it has left. So the assumption here is that the total remaining energy capacity of the battery will have fallen by 6%. Now, the reason why I say it's an overestimation is because this could be for a number of different reasons. Part of it could be attributed to actual physical degradation in the battery, in the cell chemistries of the battery. But it could also be due to recoverable losses, so things like cell imbalances. If the state of charge across the cells of the battery rack are at different states of charge, that puts an artificial limit on the total energy capacity of the battery, and these can be recovered through rebalancing of cells. It could also be operator driven. So if for some reason warranties were tightening in the market and battery operators decided that they wanted to be exporting a lower amount of their energy capacity for whatever reason, then this would be recorded as a drop in energy capacity. So the 4 and 7% figures are estimates, but they're best estimates based off the available market data. And we're going to go through why we think some of the operational strategies might be causing this reduction in energy capacity. But really what we would like to do is work with folks attending today to try and improve this methodology for further iterations, because it is, as Rasa said, quite an interesting topic for a lot of people in the market. On the operational side, the reason why we believe that batteries in ERCOT may be losing their energy capacity faster is because of the nature of their revenue strategy. So what you see here are two curves, one showing how batteries have been behaving in Texas over the past 5 years, and the blue one showing how batteries in Great Britain have been evolving over the past 5 years. What we notice here is that cycling in Texas has remained pretty consistent at just under 1 cycle a day, about 0.8 has been the average for the past few years. But the depth of discharge has been increasing. So what that means is for every time a battery chooses to export in the Texas battery market, it's doing so exporting a larger volume of its energy capacity and depleting more of its energy capacity. Now, it doesn't mean that it's exporting 30% every time. It's usually the fact that it'll make minor exports, but then the major exports are about 80% of its energy capacity. Whereas in Great Britain, over the past few years, we have seen some increase in depth of discharge, but mostly a pretty stark increase in how often batteries are choosing to cycle. We believe that this depth of discharge increasing in the Texas battery market and this relatively high average value is one of the reasons why batteries may be degrading faster than expected. Because there's a few activities that increase degradation rates, as Tristan will also point out. Depth of discharge is one of them. Operating at extremes ends of the state of charge and sustaining those energy levels tend to result in faster degradation. And to understand why Texas batteries are doing so, we can look at a few years ago what a battery would be doing to try and maximize its revenue and what that looks like compared to today. So before, batteries would throttle their state of charge responding to regulation signals. For context, regulation is one of ERCOT's ancillary services and effectively is a minor frequency adjusting service that allows batteries to be able to discharge and charge throughout the day, as seen here, to try and regulate energy imbalances on the system. And that what results in, though, is that because you're charging and discharging in small bursts throughout the day, your state of charge remains relatively flat. Whereas nowadays, with the saturation of ancillary services, batteries are now moving over into real-time energy arbitrage. ERCOT is notorious for its price spikes. And so what you see here is that power output is now a larger function, is more cyclical. And so batteries will be charging during the morning and afternoon hours, and then discharging later in the day in response to higher energy prices. And what that means is that batteries are now operating at more extreme ends of their state of charge. So they'll remain depleted for more of the day. They'll store up to about 100% of their energy capacity. This is the same 200 megawatt hour battery we were looking at earlier before discharging again. And because it's operating now more at extreme ends of charges and is exporting at closer to its maximum capacity, we believe that this behavior is now causing these batteries to degrade faster. And this is a trend that is quite normal for battery markets. You see that as the initial build out of batteries enter into a market, the majority of their revenues are earned from these frequency response services, which is shown in orange at the left here. We call this phase one at Modo. Our understanding is that when batteries enter a market, they start to participate in these fast acting frequency response services, but then switch as the market starts to get more saturated and clearing prices for these ancillary services fall. You then start to see batteries switching over into performing energy arbitrage, and that's exactly what we saw here happen towards the tail end of last year. But this is true across most markets. So what you see here is for the markets that we operate in that we believe to be mature battery markets, Texas, ERCOT being in the top left and GB in the bottom left, you notice that this trend is the same. Batteries will start to saturate frequency response services, ancillary services, and then move into energy trading. One of the reasons why Great Britain hasn't seen the same operational behavior as a result of this change is because, A, the existence of a capacity market. Great Britain's capacity market is incentivizing overbuild amongst the fleet, whereas in Texas, because it doesn't have a capacity market, a lot of these batteries are not oversizing as much as you would expect compared to GB. So GB's degradation is masked by the fact that if a battery is reporting to be 100 megawatt hours, it's actually building to 100 to 120. The reason for that is when you earn a capacity contract in the GB market, you need to guarantee that you can deliver for a certain number of hours throughout the lifetime of that contract. And if you fail your testing for that, then you lose your capacity contract. And so since capacity contracts form the foundation for revenue in Great Britain, you see that overbuild happen. It's also to do with the nature of how energy trading works in GB, where GB you see batteries cycling pretty consistently throughout the year. Texas, because of the lack of the capacity market, batteries in Texas expect to make the majority of their revenues during price spikes. So that's when the energy prices on the system go into the thousands of dollars. It's those moments where batteries really try and concentrate their discharges. And so, in short, in summary, batteries are exporting in bursts, which is why your depth of discharge is higher, and is one of the reasons why we believe that they're being utilized more at the extreme ends, whereas in GB you see more consistent cycling throughout the asset's lifetime. So that was the first half of the presentation. The second half, we're just going to go through the overall revenue context for batteries in Texas and why we believe that this energy capacity is becoming more vital. So as we saw in the previous slide, we see that energy arbitrage is becoming the largest source of battery revenues in Texas. But a big result of that is the saturation of ancillary services has meant that revenues in Texas have been falling a lot faster than what energy trading can kind of make up for. So what you see here is the Modo Energy BESS ERCOT index. So that's the way that we track revenues in the market using operational data that's made available by the system operator. And what you notice here is that the summer of 2023, so August and September 2023, because of how tight system conditions are, ancillary services clear at incredibly high prices and batteries get to benefit from this. But as saturation has increased in these services, you see revenues trailing lower and lower. And this year is set to basically trail at half what we were this time last year. To understand why, again, this is the Modo Energy Index broken down by month. You can see that May of last year, revenues were quite high. We then saw another uptick in August. If you look at where those revenues are coming from, we see that each of these colored bars from pink all the way down to blue, so this top half of the stack, these are all the ancillary services in ERCOT. And the bottom half of the stack is energy trading. So that's both from your day ahead energy market and your real-time intraday energy trading. What you see is that you don't have the same ancillary service clearing revenues that you did this year. And so more of these batteries are actually earning their revenues in the energy market. Now, the reason why these bars don't show that, and in fact, batteries are earning more of their revenue from energy trading, is just that because these revenues are normalized per kilowatt, the absolute magnitude of revenues that batteries are earning by energy arbitrage has increased, but because the build out of the fleet has also increased, the per kilowatt, so for each battery, the amount of revenue that it can earn has decreased over time. Because these spreads in the market have not really kept up with how fast ancillary services have saturated. For context as well, Texas is a nodal market, which means that prices across the network vary from point to point on the grid. What you see here, each of these bars shows a single battery in Texas. And because of the fact that every battery is exposed to its own nodal price, you see quite a lot of variation in your revenues as a function of where you're located on the grid. It has to do with operational strategy as well, which you can notice here between different colors bar. Endurance Spark, for example, makes the majority of its revenue performing in the day-ahead market rather than the real-time market compared to some other 2-hour batteries. But the point for this slide here is to show, A, that 2-hour batteries tend to earn higher than 1-hour batteries do, and this is expected. They earn more of their revenue from energy arbitrage. 1-hour batteries, because they're limited in how many cycles that they wish to do per day, will reserve more of their capacity in ancillary services, which are the colored portions of the bar. So you can notice there on the 1-hour side, those green and dark blue portions of the bar are much larger than they are for the 2-hour batteries. And the reason for that is these are paid out as a capacity payment. And so just for being on standby, you receive these payments, you can limit how much you're cycling and earn revenues for doing that. And that's more advantageous when you're a 1-hour battery. But because these ancillary service products are starting to saturate, you're going to start seeing more of these 1-hour batteries shift to 2 hours. So they'll augment their sites. energy capacity is becoming ever more vital to try and stay above the market average, which if you're an investor in these batteries, you're going to want to make sure that you're maximizing how much your battery can do, especially with revenues being so low as they have been in 2025. And so the point here is just to say that energy capacities are becoming an ever more vital part of trying to make sure that your battery is being able to earn outsized returns compared to the rest of the market, and you earn a decent IRR. But that's the extent of the presentation so far, and I'm very happy to field Q&A after we go through Tristan's section. So Tristan, I'd like to hand over to you.
Thanks a lot, Ovais, for giving us a better insight on the methodology of these two studies. Tristan, I see you are joining us on the show. So let's hand over the virtual microphone to you, Tristan, and we'll leave the stage together with Ovais. We'll be back. Thank you.
Yes, thank you so much, Raza. Thank you so much, Ovais, for the introduction, and thank you so much as well for showing us a glimpse into the real world of battery systems and how they are being used in different setups and in different markets. Let me now please go into the topics of my presentation for today's webinar. Now I have it. The major contents will be a short overlook of the data-driven inspections that we have here at Sinovoltaics as parts of our service portfolio. A closer look at temperature as being one of the major multipliers for battery degradation. A zoom in on thermal management and how you can really check those parts and that part of the battery storage system prior to shipment. And how we, with Bessential, have put a service in place that shows you on a forensic level almost on those issues that we find during those FATs. So just as a basic generalization, when you're looking at battery FATs, there is, I would say, a traditional part of an FAT, which some of you that joined this webinar will know, which is documentation supplied by the manufacturer of the battery storage systems. This can be somewhere between 12 to 26 points. It's typically a very standardized document that is being handed to you. What happens there is one of the major points, if it's available at all, is a so-called performance test or a capacity test, in which there is one discharge and one charge cycle with typically a half-hour rest in between cycles. This is basically the groundworks for what you have contractualized with your supplier. If you are, for instance, an asset owner, an IPP, or actually the buyer of that asset, then you will have contractualized a certain amount of capacity with the supplier. And this test basically shows how much capacity is available in that given asset. Now, typically in FATs, 10% of those assets are being checked for capacity. So if you have a 10 container project, one container is going to be sampled and then capacity or performance tested. As we at Sinovoltaics take pride in our vision, it is something that is really deeply ingrained with how we work and what we work, which is that we are looking for zero risk in your projects. We have developed our Bessential services, which allows you to have a deeper look into the data that is being provided with that very capacity or performance test that is being done, hopefully at the FAT. I will get to the point on why this is important and why you should care. What happens there is during the performance test, one total cyclical run of the battery is being done. And this data, in a perfect world, we are able to receive this data, and with the data points, we can make you, or we can allow to have a report showing you exactly how your asset functions and what doesn't work and what works really well. If you want to think about Bessential, maybe you want to think about a house for a traditional FAT. With Bessential, it's not only a house or a building, but you can easily look into the rooms and even the drawers of that very house. As mentioned, in this case, we not only inspect like the container on a container level, but we really go down to the battery packs as well. This is not coming at any additional issues for the supplier in terms of logistics or time, because performance tests are hopefully done anyway during the FAT of your asset. This raw test data is then analyzed by a Sinovoltaics. We will have a look at the data that is being provided, and we will have an answer for you in the next 24 hours what we have noticed in there, if there is any typical or large deviations within your asset. Now, I would like to jump on the top 3 impacts on degradation, because that's the topic of our webinar today. And Ovais was very much so in the depth of discharge and the C rate function here, which is mostly operationally controlled. What I would like to have a focus on today, especially, is the temperature, which has one, if not the largest impact on the degradation of your asset by far. And if you're looking at degradation, the multiplier could be anywhere from 3 to 8 times higher than the baseline. For the baseline, typically suppliers look at the 25°C line. This is something that has to be please kept in mind throughout the presentation that I'm doing here. One of the probably most known curves is the Arrhenius curves. For all those that are not really familiar with it, it shows you that at different temperatures and at different, if you really want to go one step further, you have to also think about the C rates here as well, obviously. But if you're looking at the temperatures here, the type of degradation you are witnessing from 25 to 55 degrees is massive. So I always try to find one nugget during webinars that is really standing out. So if you want to have one key takeaway from my presentation today, then please let me tell you that as a rule of thumb, roughly twice the degradation happens with every 10-degree rise in temperature. So this is one thing that is overlooked a lot of times during FAT and or subsequently during the testing of your asset prior to shipment to your project site, wherever that in the 84 countries that we are having as guests today might be. As mentioned, I would like to zoom in on the thermal management part of the presentation here, and especially on the temperature part here. Why is that so important? So typically thermal management and the parts of the thermal management, we can probably have a very long discussion about this and which parts do apply to the thermal management. Coming from the QA/QC part of this, what we typically see is 2 units that are regarded as the thermal management part during the FAT or in the documentation of the suppliers that we are visiting. So this is across the board. It's not a generalization of one supplier or the other. It's what we have witnessed in the field. And those 2 parts are typically the liquid cooling and the liquid coolant system check as being part of your FAT. And the other part is the check of the cooling and heating system. On the right-hand side, I tried to find some screenshots of typical FAT standard documentation that we see from various suppliers with various testing methods and with various, if at all available, pass and fail criteria for those important FAT points. One test subject which we rarely or basically never see, which is non-existent in the testing that is being done during the FAT, is cell level temperature check. And in our opinion, it's one of the most important parts to counter degradation early on in battery life. So how can you do that actually? while I have mentioned that Essential is basically looking into the apartments or even the drawers of a battery storage system, if you want to have this visual in your head, we also look at differentiations and also in between the line information for temperature issues with the battery system. What does that mean? It means that we are not only looking at the threshold value that has been contractualized, but we are also looking at the differences of the temperature. Why is that important? The higher the difference in temperature is, the more different degradation rates might be during the real world use of your battery storage system, leading to probable loss of income for your asset as a whole. This might look a little bit interesting on why I have chosen this particular slide, because the threshold is so much higher than what we have witnessed or what we have measured during our Essential. But the reason I chose this slide is to sensitize on the next topic that I'm going to touch upon, which is the preparation or the fixing mechanism basically for the temperature issue or the degradation. Now, in this case, the threshold value for the temperature was extremely high. It was set at 60 degrees. The sole reason for this was that by the time that we were able to carry out our Essential services, the contract was already in place between our client and the supplier. And the chosen or contractualized threshold was at 60 degrees, which means that it is a very, very high value. And even though we didn't reach it or we didn't fail the test, if you have a look at it, it's almost impossible to do so. So if you want to take away a second thing probably for this webinar today, I encourage you to have someone have a second pair of eyes looking at your performance guarantees, at the contract that you are setting up with your supplier. It is very much so that down the line, those contracts can actually cost you a lot of money or a lot of revenue, or in the worst case, both of them. You might ask yourself, okay, so but what does this mean in hard truth fact? When we do or when we are allowed to carry out our Essential services for our clients, what we have noticed is that 2 out of 3 containers, or 66% of every project, or 2 out of 3 containers as mentioned, we find issues. So these can be very vast. They can go from temperature, they can go from voltages, they can reach to round trip efficiency issues, they can be all sorts of issues that we find during the Essential services. Again, as mentioned, in this course or in this webinar, we focus more on the temperature side of it. And so while we were running up this webinar, one of the things that we have noticed, because I like to look out on LinkedIn if there is like feedback already for the webinars prior into going there, and one colleague mentioned, rightfully so, that from his experience there shouldn't be any issue, because all the performance warranties and all the SLAs with the supplier or the technology provider will take care of this. And I 100% and wholeheartedly agree with this. However, from our experience, it really means that the contract has to be pitch perfect and all the small details have to be ironed out perfectly. The reason for that is, if you take your time once and read through the whole warranty and the procedure of it, it is very, very tough to find a solution for a lot of those things that are being mentioned in there, especially temperature, while most of the degradation curves and the performances that are being guaranteed are on the baseline of 25 degrees. Very often so, it's lab test conditions almost that you have to claim those things. And as mentioned, I encourage you to have someone else have another pair of eyes looking into the performance warranties and the SLAs that you close down with suppliers. It really helps to nail those issues that might come up at the later period or at the later stage of your project, and make sure that the asset runs in a perfect and smoothly way and the degradation meets your requirements. Yeah, that was my part of the presentation. Thank you so much for listening in. Yeah, Radha, I would like to hand you the word.
Thanks a lot, Tristan, for very insightful presentation, a technical one. But I think now we get a better understanding on what lab tests can help you actually get the best quality of BESS, and that will prevent your BESS systems from a faster degradation. Thanks again, Ovais, as well for you for also insightful presentation. We received a record number of questions, and they keep flowing in. So let me put on the Q&A slide here, and we can start addressing these questions. All right, let me see, where do we have them here? Okay, a question for you, Ovais. A question coming from Jose Luis. Was maximum exported energy in between imports measured after a cell balancing? Not sure if cell unbalance or imbalance might have a certain impact on measured degradation.
For sure. No, I don't think so. Using the export data wouldn't be able to indicate whether or not there was any cell imbalancing happening. So yes, it could very well be that on particular days where there's smaller amount of energy exports observed, it could be that that is due to cell imbalances. However, over the long run of the project, because it is looking at the maximum exports over the entire lifetime, the specific days where a cell might be imbalanced would just not appear as the maximum against which you are recording losses in energy capacity.
Okay, thank you. Another one we have is from Augustinus. Again, Ovais, to you. Do you start to see arbitrage margins shrinking due to competition? Does that mean future BESS deployment should focus hybridizing with renewables and less as standalone?
It's a great question. I guess it's $1 million question, actually, of whether she should stick with arbitrage. Partly to do with BESS competition, yes, but mostly just to do with the fact that in a market like Texas, it's actually quite an unusual case where supply has come before demand. And so the large load conversation, aka data centers in the US, one of the reasons why Texas is quite a big hotbed for this is because power is cheap, because you have an oversupply of both renewables and battery storage and other dispatchable generation. Sorry, to answer the question, arbitrage margins have remained low, partly due to competition, but partly due to the fact that there's not a load on the system yet. We see these increasing going into the future as more demand growth happens, especially in the western part of Texas, which is quite industrialized. We see a lot of these oil and gas operations that exist out west to start electrifying their operations. On top of that, we also see companies like OpenAI opening up their Abilene data center. And so a few of these larger projects are going to add gigawatts and gigawatts of demand to the system. And so we see these spreads hopefully increasing towards the end of the decade. As to whether or not that means batteries should be deployed as part of a co-located hybrid solution or standalone, I think it depends on a case-by-case basis. Again, because it's a nodal market, it means that, say, for example, if you're located in the very southern tip of Texas, where there's quite a lot of excess wind generation, it might not be beneficial because you would not be able to arbitrage price spreads as well. Price spreads are actually or prices are quite depressed in the very southern part of Texas. Whereas if you're just outside Houston, for example, which it means that there's a lot more demand, which creates spikes in prices towards the evening. And it's actually more beneficial to help solar adjust its hours outside of the midday trough. So yeah, again, a case-by-case basis, but I don't think the standalone business case is going anywhere.
Okay. Okay. Thanks a lot, always, for such a comprehensive answer. Another question we have for Tristan. This is coming from Leo. Thank you, Leo, for your question. So you need to actually charge and discharge the BESS to do your test. Does all the supplier have a test bench in their factory to do so?
Hi. Yes, thank you so much for the question. It's a good question. Unfortunately, not. So I would argue that the majority of tier one suppliers that you typically know and where the names float around, they have the capabilities and the capacity to really carry out those charge and discharge tests for you. Unfortunately, there is a little bit of a pushback or a drawback of this, because as you can imagine, a lot of the suppliers have high logistical challenges, I would say, to make the FATs run smoothly and the production run smoothly. So there is only so much time between the production, the end of line or FAT tests, and then the shipment of the assets in order to have the performance tests work for all the time. So what we rather see now from our experience, that a lot of the parts from the FAT are being pushed more into the production. So it's becoming more of an inline FAT inspection for some projects in order to raise the capacity test possibility. But to answer the question really shortly, yes, most of them do have the capacities to do so.
Okay, thanks a lot, Tristan. I have another one for you. Let me see. Let me see the questions real quick. Is it sufficient to follow the factory FAT standard, or do you recommend additional testing? I guess you also touched upon that, but maybe you can elaborate a little bit more.
Yes, it's also a very good question. Yes, I've touched it in the presentation, but basically the FAT standards that are being provided by most of the suppliers are somewhat of a standardized situation. So let's say you are practicing for 100-meter sprint, then you are going to be really, really good at a 100-meter sprint, but you might have issues doing hula hoops or I don't know, being bad at breakdancing. So what we are saying here is that the FAT test, the standard ones, it's good if you have it in the first place, because not everybody is providing this information, unfortunately. But what we would recommend is to really tailor it to your requirements, if possible. If you start questioning a lot of those FAT tests and the documentation of the suppliers, you will see that some suppliers will be more welcome and more open to help you and to increase the quality level to match your requirements. Some won't. So for me, this would be a red flag, honestly, to see if there is too many pushbacks to make your quality work.
All right, thank you, Tristan. I have a question for you, Ovais, coming from Andreas. So in the two studies that you presented, are you only considering charge and discharge cycle as the only reason for the battery degradation? What do you consider as the percentage of the degradation due to charge and discharge cycle only?
I'm afraid I won't be able to answer the second one, only because a lot of these things are quite integrated. So it would be a combination of both charging and discharging cycles and C rate, so both depth of discharge there and then how quickly those cycles are being accrued. The full analysis does do a segmentation of what the what amount of degradation, or rather whether degradation rates are observed more in batteries that are doing higher depth of discharge or higher cycle ring rates. But those are the two things that we look at. Unfortunately, we don't look at temperature because we don't have insight into the thermal management systems for individual batteries in the market. However, we do a bit of locational analysis as well that again, in a place like Texas where it can get quite hot, you do see some regional variation across the state. I'm very happy to link out to both of the studies in the follow-up email, along with the slides for anyone who'd like to see more details behind what the analysis was. But to answer the question, I think it's not the only reason why batteries degrade. It's not the only reason that was analyzed in the full piece.
All right, thanks a lot, Ovais. Let's see what other questions do we have. Right. Also, again, question for you, Ovais, related to the studies that you presented.
Of course.
The depth of discharge chart shows a relatively low depth of discharge. 30% depth of discharge means a discharge to an
state of charge of 70%.
And can you please explain?
So averages, right? I think there will be days where, and it's averages both across the time period of the year, but also across batteries in the fleet. So say, like we saw towards the tail end of that presentation, some batteries might be using ancillary services to make up the majority of their revenue. These services see low energy throughput. And so really the reason why that 30% depth of discharge number seems quite low is because you'll have your 2-hour batteries that are doing regular cycles and dispatching up to 80% or 90% of their state of charge, whereas you have some cycle that are only doing 20% throughout the course of the day, really because they're operating in these low energy throughput, say, for example, regulation services. All in all, the answer is that that's an average number, but you can see how it compares to the GB average and then make an assumption about overall operations through those averages.
Okay, thank you. Another question for you, Tristan, coming from Ladislava, if I'm pronouncing it correctly. What would be your recommendations for contractors? What exact certificates, FAT information, and warranty conditions they should require?
Well, for the certificates, obviously, a very localized certificate string has to be applied dependent on where your system is going to. I would also encourage you to add those certificates as being part of the FAT, just to make sure that this is also checked during the end-of-line tests if you have a battery storage project. When it comes to I'm sorry, I'm just looking for the question. So this was the part with the certificates. I'm sorry, may you just read it again rather real quick? You're on mute. You're on mute again.
Oh dear.
I'm sorry.
What are your recommendations for the contractors, and what exact certificates, FAT information, and warranty conditions they should require from manufacturers?
Okay. Yes, thank you so much. I'm sorry. So this is the part of the certificates. What is really, really important is also to make sure that definitive pass and fail criteria are being explored in your FAT and in the documentation between you and the manufacturer. And I would highly encourage you to derive those pass and fail criteria from the technical tender that you have issued or the data sheets that have been provided to you, or to use any baseline for that. Unfortunately, right now, what we see is some sort of a YOLO approach, which means that a lot of the pass and fail criteria are not really defined in the first place, but are kept open if it's an open answer to a question that is looking for a binary answer. So I would highly encourage you to do that. When it comes to the guarantees and the performance warranties, I would also just say that make sure that the lingo is correct. A lot of times syntax is being used in the contract that is not purposefully misleading, but it is purposefully making things complex. So I highly also encourage you, if you have any questions, please reach out, and we can have a discussion over this.
Okay, thanks a lot, Tristan. I have another one for you, so you can stay unmuted. Can you please advise if you got the cell temperature with the Bessential or from the supplier's test? Also, is Bessential available to the public?
Okay, so number one, maybe I wasn't 100% clear then in the description of the process of it. So during the FAT, there is going to be hopefully a performance test. During that performance test, data is being generated, which is mostly being saved, or it's stored on your BMS. So what we do is we receive the data that is being stored via the BMS, and we are reaching out to the supplier in the name of our clients to receive this data, which can be an XLS sheet or it can be a CSV document, and it's then being analyzed. So actually this data is generated either way. And either way, if you're choosing to use our services or not, it's your data. So you have absolutely the right to get this data in the first place, because at the end of the day, it's your asset. And yes, it's available to the public if you get in touch with us. we are very it's not something that you can. It's not an open source software. It's a proprietary service that we have here at Sinovoltaics.
Good. Thanks a lot, Tristan. I am aware of the time. We are unfortunately running out of time, and we have so many questions still to be addressed. I'll take just the last question. This one is for you, Ovais, if you don't mind. A question coming from Jo, if I'm pronouncing it correctly. So 2-hour BESS makes more revenue than 1-hour BESS, but can the added CapEx and OpEx be offset by the extra revenue?
So 2-hour batteries would definitely make more revenue than 1-hour batteries in most cases. Again, depends on how much more. And really what we're seeing is that the revenues that you earn for having extra hours of duration are offsetting your costs of augmentation or for going for the 2-hour battery straight out. In fact, in this past quarter, we saw a record number of capacity come online in ERCOT, almost 2 gigawatts. Almost entirely of the entire stack of that was 2-hour batteries as opposed to 1-hour batteries. And so these are investors who've kind of started these projects a few years ago. They're now entering the other end of the interconnection queue and actually achieving commercial operations. They came in with the thesis that around this time you will have longer duration batteries that are earning higher IRR multiples given the current state of the market. In fact, we see that extending even further into 4-hour batteries as well. So what people can expect going into 2026, so far, a place like ERCOT in Texas has had primarily 1-hour batteries, then more recently 2-hour batteries, and we're now then seeing 4-hour batteries coming online as soon as a few months away. So that's really showing the fact that those extra hours of duration are becoming essential to try and capture those energy arbitrage spikes, particularly as they move later and later past sunset, which is usually when those prices spike up as solar comes off the system. So yeah, definitely. I think the general thesis is that the extra duration is worth it.
Okay, good. Thanks a lot, Ovais. Let's wrap up today's webinar. I thank you both to our speakers, Ovais, Tristan. From the number of questions we received, I understand that the question was really insightful. The questions that we were not able to address during the webinar, we will follow up in a written answer via email. And I guess we can conclude one thing, at least that's what I'm, bringing back from this webinar to myself, is that BESS systems might be degrading faster because of different reasons. It could be market revenue strategy, a perfect example of Texas electricity market, then depth of discharge and, or extreme charges, etc. And this is not only a technical issue, it is also a financial, operational, and a strategic one. So I hope that today's discussion equipped you with the clarity and confidence to take the next steps for your BESS projects. And thank you again for joining us today. And we look forward to supporting your journey in the BESS assets and deploying BESS assets. If you need any advice or consulting on PV and BESS quality assurance, reach out to Sinovoltaics. And if you need any renewable energy market insights, you have Ovais email address on the screen. So I thank you all again, and see you in the future Sinovoltaics webinars.
Thank you, everyone. Thank you, Rasa.
Thank you, everybody. Bye-bye.
Visit sinovoltaics.com to learn more.